Hi guys, today I'm going to teach you about the topic which is angiotensin 2 and its effect on the GFR. So what is your angiotensin 2? So angiotensin, where it come from? So angiotensinogen, which is present in your lung, right? So angiotensinogen is converted into angiotensin 1 with the help of the enzyme renin. What condition? When you have decreased renal blood flow and the sympathetic stimulation. This renin, where it comes from? It comes from your juxtaglomerular apparatus. Juxtaglomerular apparatus, right? So when this angiotensin 1 is formed, it is inactive, right? It then go in the blood towards the kidney, where it is get converted into angiotensin 2, which is your active enzyme. With the help of the enzyme, angiotensin converting enzyme, it is present in your kidney. So this enzyme is present in your kidney. Now angiotensin 2, what does it do? Number one, it causes the efferent arteriolar vasoconstriction, which is required to maintain your GFR. Secondly, it causes the systemic vasoconstriction, which is required to maintain the blood pressure and increase the blood pressure. And third important effect is it causes the synthesis of your aldosterone, which is it synthesized from the adrenal gland. So aldosterone, it causes increased sodium and water reabsorption along with your increased sodium and water absorption, and also it causes increased potassium and hydrogen excretion. So sodium and water is reabsorbed from the renal tubule into the circulation, while from the blood potassium and hydrogen ion is excreted into the tubular fluid. By reabsorbing sodium and water, you basically increase your blood pressure. So now this is very important graph over here. You will see it in your question stamps also. So what this graph? In this graph you are seeing the three important parameters. So if you see on the x-axis, this will show the efferent arterial resistance, right? And on the y-axis, on your left side, so this is your left side, this on left side y-axis, this is your renal blood flow. Then on the right side of this graph, on the y-axis, this is showing the glomerular filtration rate. Now we have to discuss over here that how these parameters are related with each other. So before going into the depth of this graph, I want to show you that what line represent over here which thing. So this on x-axis, I told you, this is your efferent arterial resistance, that is 0 to 4 when you are going towards the going from the left towards the right side. So this is your efferent arterial resistance. This dash line over here is representing your renal blood flow, and this dark green color is representing your the glomerular filtration rate, right? So now we first discuss about this dotted line. So whenever you increasing the efferent arteriolar resistance, what would be effect of this increasing efferent arterial resistance on your renal blood flow, right? So this is your renal blood flow. Let's say it is the normal or 1600 somewhat. So when you are going this way, your renal blood flow will be go down when you increasing the efferent arterial resistance. So how you impact this efferent arteriolar resistance? So you will do what? Let's say your efferent arteriolar resistance is 1, right, which is normal. So you will go straight up to here and then draw a line this way. So that is round about 1300. So at 1 efferent arterial resistance, your renal blood flow drop down from the or is normal, which is about 14 to 1300. This one level of efferent arterial resistance is pretty much normal, right? And at this point you can calculate your GFR by draw a line towards the right side of the y-axis. So this is denoting that your GFR is 100, which is normal. So that why we are saying x is normal. So what is x? Let me draw over here again. So x is this thing. So this is your x. So this is saying that x is your normal, mean that at 1 arteriolar resistance, your blood flow is 1300 ml and your GFR is 100, which is pretty normal, right? Now they change the efferent arteriolar resistance on the x-axis, and you will see how it will affect the renal blood flow and the GFR. So let's say you are moving from 1 to 2. Now what would be the effect on the renal blood flow? You will draw a line from 2 to above this way, and then you point towards the left side on the y-axis. So it is denoting that now this is your normal point. From normal, your renal blood flow go down up to the 800, right? So now you have to calculate what would be the effect on your GFR. So what would be the effect? Now you draw here the line straight up to here, right? And then which touch your GFR line, and then to take it towards the right side, which is denoting that your GFR become like 130 or 120 ml per minute, which is increasing. So that is what denoting that whenever you increase the efferent arteriolar resistance with the help of angiotensin 2, your renal blood flow will be dropped down while your GFR will be increased. But what important thing you have to understand over here, that when you increase, greatly increase or more, you move or you increase the efferent arterial resistance, that will one point drop your renal blood flow, but it will affect on the GFR, that it will decrease. Now I'm telling you over here. So from 2 you are going on the point 3, right? Now you have to calculate from 3 point, you draw a line up on the this blood flow right over here, then you draw line over here. So you're now from at 2 position your blood flow was 800, at 3 your blood flow is up to 400, right? Now you draw a line above over here which is touching your GFR. So initially your GFR was right above here. So this was your GFR when you increase the efferent arterial resistance from 1 to 2 line. But from 2 to 3, what is your GFR? I'm just changing color for you to understand. So this will you draw up to here, and you can understand now your GFR will be dropped down from 130 to almost 120, and at point 4 further increasing, your blood flow will be dropped down further and your GFR will be dropped down further over here, right? So this is all this graph is showing. Now how this is happen actually? So for this one you need to understand a little bit mechanism. So this is your glomeruli, right? This is your afferent, this is your efferent, and this is your Bowman space. This is how I represent the kidney, like a nephron. So this is your afferent, this is your afferent, this is your efferent, and this is your Bowman space, right? Bowman space. So blood flowing is right in this direction. So blood come over here, then it go down over here, then this way it going into the efferent arteriole. That is the normal. So what is happening when under the influence of the angiotensin 2, you will blocking over here, right? So let's say you're blocking blood over here, like this is constriction I'm showing this way, right? So now what would be the effect on the blood? So what would be the effect on the blood? So now blood will come this way, go this way, and then try to go over here, but due to this blockage it come back and go down. So there in this area you have increased hydrostatic pressure. This hydrostatic pressure or the water pressure lead to increased GFR. That is showing in the graph over here. When you move from 1 to 2, that is what your renal blood flow will be dropped down because you are constricting over here, and your GFR it will be increased where you are increasing the hydrostatic pressure over here, right? So what is happening when you increase the hydrostatic pressure over here? So you are filtering the things, but behind you are increasing the proteins, right? Over here the proteins are left because you are not filtering the protein over here. So what is happen when you further increase this resistance? That is when you go from point 2 to 3, you are constricting more this area, right, with the help of angiotensin 2. Now what is happening? Now the blood flow is like this. Let me drop down here. So how the blood will flow like over here? It will go move like here, go like this way, then going, but this is too much blockage. Now it is reversing black over here. But all this process when it is happening, You are removing the water from the glomerulus into the Bowman space, but same way you are leaving the protein behind over here. So what happen, as you know, when proteins are increasing, they will cause the increase oncotic pressure, right? So what does this oncotic pressure will be do? Oncotic pressure which is produced by this oncotic pressure which is produced by your proteins, right, over here. So this oncotic pressure is produced by your kidney. Sorry about that. So this uh, oncotic pressure, which is produced by your by your proteins, it will causes what? It will causes reverse of this filtration. Like now the water going this, instead of going this way, your glomerulus will be start reabsorbing water, or your glomerulus will be stop more filtration or decrease down the filtration due to increase of the protein over this area, right? So that is one what happened over here. If you go in the graph, when you are moving from 3 towards the 4, so what is happening? Your GFR will be down, your blood level will be decreased because of this obstruction, but your filtration GFR will be reduced down. That is what's happened in this case. So this is the best way to interpret this graph. So I will come back again with another important topic. So stay tuned with me. Thank you so much, guys. Thank you.